Good evening, people. I've got a HP 15 series laptop here. The issue with the laptop was that it was totally dead. There was no power at all. There was no light on the DC port. When I've connected to my bench power supply, the recommended power for this laptop is 19.5 volt, 2.31 amp. It wasn't drawing anything. It was showing up as 0.00 amp. So I stripped it apart, try to figure out what's going on, and yes, I have a solution to the problem basically. Okay, so let's go on to the schematic of the board. This tripod is a bit of a nightmare, so you'll have to just bear with me while I'm lining up this tripod. Okay, I think this is fair enough. Okay, so here we have DC jack. You've got 19.5 volt going across through this way. You've got the inductors, and then you've got a MOSFET. At the drain, I had 19 volt, and at the source, I also had 19.5 volt, and at the source, I also had 19.5 volt, which effectively means that the gate is working. And I couldn't remember the measurements of the gate, but anyway, that's beside the point. Let's move along. Okay, so then on the PQ20, which is also an N-channel MOSFET, part number QM30160. Okay, and I have the data sheet for that. There you go, that's the part number, which is an N-channel 30 volt fast switching MOSFET. And that's the type of MOSFET we're looking at. I don't think anything else is relevant at the moment. Okay. Pin number 4, according to schematic, and according to the data sheet, is drain. I had 19.5 volts up to there, but the source, pin number 3, there was nothing. So the current wasn't going through, which effectively means that the gate is not closing to allow the current to go through. So what I've noticed on the internet is that people are bridging wires from drain to source basically, and then the laptop works. And just out of interest, I did that with this laptop, and it worked. Turned on, it turned off absolutely fine. It works through the adapter, it works through the battery. But there is a big but, and that is that it was not charging the battery. Because obviously the switching has to take place, and then the battery charge, once you've got the appropriate voltage going through here, I can't remember what the voltage on that point before and after, because I've just been silly busy, that this will then end up to the battery charging section basically. So this is actually a battery charging IC, okay, and one of your main power management IC for the rest of the laptop. Because obviously if there is no voltage here, it's not allowing 19 volt to go past to the rest of the board. Effectively what that means is that the laptop is dead. Okay, so that's what I mean. Anyway, so the situation what I had is that it would run off the battery, providing that the battery is charged. It would run off the mains. Even if the battery is connected and the mains connected, it will run fine, but it won't charge. Battery will not charge, and I'm repeating this. Okay, so what the wiring side of it, I want to get things done the proper way, and the proper way is to sort of check this N-channel MOSFET, make sure that there's no leakage or it's not faulty. In my case, luckily I had a spare board, HP board, as I said before, that I have a couple of them that needs looking into, and I've replaced this MOSFET. Obviously there was no, I did that just for curiosity, but there was no voltage at the gate. Now because it's an N-channel MOSFET, the gate voltage has to be higher than the drain. Now the drain is 19.5, the gate should be in the region of 25.5 volt, but there was nothing there coming through from the AC drive of this IC basically. Everything else works fine. once you loop the wire, you're getting all the voltages and everything, and you've got the upper MOSFET that was reading something like 16 volt, whatever it was. The lower MOSFET was reading 0.4 volt, whatever. So the switching was sort of kind of taking place, but it wasn't charging the battery. I can't remember what the voltage was, but it's the top of my head. But anyway, let's move on basically. So what do we have in between this line basically? Our 4.0 kilo ohm resistor, which are the PR22, a couple of capacitors, and then you've got the gate basically. So you've got a capacitor here which is 0.1 microfarad, 50 volt. These are small capacitors, and then you've got another capacitor which is PC118, 2200 picofarad, 50 volt again. And I think these are number 4 is the 0403 package and 0603 package. This is what it is standing for at the end, number 6 and number 4 basically. So okay, so how did I go about resolving the problem? Obviously the wire thing had to come out because that's absolute bollocks, because it wasn't charging the battery, providing that the laptop was working. There was no voltage at the gate, and I was expecting around about 25 volts, 25.5, whatever it is. That wasn't there. So what I did is I ordered some IC, the BQ24738H, okay? Replaced it, put the original MOSFET back on, and bingo, the laptop's working. Okay, let's get this down here. There you go, the laptop's working off the battery. Okay, I've got 96.4% charge. I'm going to plug it in. I do get an amber light at the side. Let me take this off. You can just about see the amber light there, the charging light. Okay, and 96.4 it was. We'll just wait for it to increase. Let's see if you can see. Just zoom in a bit closer. Okay, and that software will refresh itself eventually, and we'll just have to wait till it jumps into numbers basically. So give it a few more minutes. And it's Windows also showing that it's 10 minutes until full charge. Let me show you some. Okay, where's it gone now? There you go. Okay, so let's go back onto this and just wait. It's just pity that, well, no, I wouldn't say pity, it's just I don't understand how people sort of repair these with the wire, and it works. I just couldn't get around understanding. I mean, these are all the controller ICs what I bought off the internet. I don't know if you can see them. All of them. These have been ordered in just recently, and I got them off AliExpress. They were cheap enough to buy. I got them in a pack of 5. Usually I'd buy a pack of 10s, but sometimes it's just collecting dust. So there you go. These are the ones what I ordered. We'll wait for the battery to sort of charge to increase. Whether that through the utility or through Windows management doesn't matter. But these are the 4 different type of controller ICs I've ordered. I've used one out of the pack, but smashing. It's done the job beautifully. Let's see what's happening. Right, what I'm going to do is I'll refresh software. Okay, and as you can see, that there's a bit of a softer hang. It's 98.2% charge. Okay, let's see what Windows showing. 98% charge on Windows as well. Let's sort of show you what's going on. There you go. Okay, so I'll quickly shut down the laptop. This proves the fact that the laptop is working both ways. It's charging and with the battery and whatever the problem it was. Right, okay, so what I'm going to do is You know, it's very important to make a note of the pinouts, the voltage on the pinouts, and on this particular one, the HP15, maybe just for your reference, let me sort of tell you what the pinout reading should be, because that helps to understand what's going on as well. So let me sort of show you. So on, let me grab this. Starting from the pin left one is 16.57. Next pin 16.57 again. Next pin 3.317 is fluctuating between 3.2 and 3.3. 3.3, 3.2 again is fluctuating. 0.007, 0.007, and then those two are the ground. 0.000, 0.000, 0.000. Okay, so that's that. That's the reading without the adapter connected. Let's connect the adapter. It's not going to make much of a difference, to be dead honest with you, so let's sort of test these points again. Okay, so it's the voltage with the AC adapter plugged in with an amber light, charging light is on. It's 17.04. Can you actually see what I'm doing? Could have done that, sorry guys. Okay, so with the adapter plugged in, there you go, that's the voltage. That's pin 4 from the left. Pin number 5 from left. Pin number 6 from left. And these are going to be the grounds anyway, so that's that. Okay, so those are the voltages that are present with the charger and the battery connected. But anyway, let's get down to the actual repair. So we'll shut it down, move all this away, and drop this tripod. Okay, make sure it's switched off. Take this out. Take the battery out. It's quite a bit of a messing around. Just make sure that you're getting the maximum view. Okay, always ground yourself. Take this off. Take that off. I just want to sort of show you very quickly before sort of ending this video as to what I've changed. Obviously I've discussed it before, but discussing it and showing it is kind of a two different concept. So let's crack on with this, and it'd be nice to sort of give you an insight of what's gone on, rather than running wires and all this and that. Get it done properly basically. So let me put this laptop here, as long as there's a good chance that it's going to drop. Okay, here's the logic pod. Okay, and this is the MOSFET was what I was referring to, which is the PQ20, which is here. Let me get a set of tweezers. Can get enough good light. I'm not getting enough light, so that's going to be really hard. That's your PQ20. This is the N-channel MOSFET basically. So the drain, your source, and your gate. Okay. So again, I mean, I wish I had a bit more light. I don't understand what's going on here. But I was like, let's see if that sort of gives. Okay. So I repeat: your drain, source, and your gate. I was getting 0 volt here. I was getting 19.5 volt here. Nothing that was going across basically. And really, on a normal term, there should be 25.5 volt here. Because it's an N-channel MOSFET, the gate voltage has to be higher than the drain. So for it to allow current going across to the source, and that wasn't the case. So there were a few capacitors online, as I've explained to yourself, the PC118 and the PC119. I've checked and there was no short on those capacitors basically. I've done an ohm test on the capacitors basically just to see if they were reading 0.00 ohm, but they were giving me high values, which effectively means that I'm led to believe that the capacitors are fine. There's nothing wrong with the capacitors. Okay, now this is where the main problem lies. Okay, so on this there were two resistors that was also in line. So the PR22, which are 4.02 kilo ohm resistor, 0.03 package, and then the PR 212, again it's a 4.02 kilo ohm resistor. Those both resistors were giving me 4.0 kilo ohm value. Okay, so when I probed around, everything else seems to be fine. All the pins, the VCC was fine, quite obviously, because otherwise the laptop won't turn on. That's when I was running, when I didn't have the this charging battery charging IC, basically the BQ24 738H. I didn't have that in stock, so I could not test it. So I've run a wire and then just sort of figure out what's going on basically. So all the other voltages are sort of working, and I've made a note of everything, but the AC drive had 0 volt, so I've replaced this, and thankfully it's resolved the problem. I'll probably give you a quick view before sort of switching the video off. Let me see if I can get a microscope view of the new controller IC that was replaced. Give me a sec. Let's just line this up. Thanks to Vision Engineering for building something absolutely phenomenal, but almost made a perfect. They made a perfect microscope, but unfortunately they didn't. Right, okay, so let me sort of see. Okay, that's the part. Zoom in. And that part was replaced. And from pin number, the gate started giving me 25.5 volt, which effectively means that the laptop was running as it was designed to be, and it solved the problem. So hope you guys have learned something. These problems can vary from board to board. You can have a bad resistor, you can have a bad capacitor, you can even have a bad IC in my case, which wasn't giving out the required voltage at the gate for the PQ20 MOSFET to release the 19.5 volt from its drain to source. So the problem can vary, but as I said, I've seen people running wires. Don't do that. If the customer needs to wait, then let them wait, and do it properly. But if it works for you, then it works for you, but I wouldn't do it that way. Anyway, that's all. Hope you guys have found this video helpful. All the best, and you take care. Thank you. Bye for now.